Okay, in this video we'll be covering nomenclature naming compounds for organic chemistry. So before we begin, we must understand alkanes. So if there was one carbon, what would its name be? In this case, it'd be methane. If there was 2 carbons, it'd be ethane. 3 carbons, it would be propane. 4, butane. 5, it would be pentane. 6 would be hexane. 7 would be heptane. 8 is octane. 9 is nonane. And 10 is decane. So before we start naming compounds, you must understand these, because if you don't, you probably won't be able to continue. Okay? So let's begin by trying to name this compound. Okay, so how do we start? Well, you have to find the longest uninterrupted carbon chain. And in this case, it's very straightforward since there's no substituents. So you could start from either side. 1, 2, 3, 4, 5. So since there's 5 carbons present, the name for this compound would be pentane. Very simple. Okay, so let's try this example. How do we start? Again, you start by finding the longest uninterrupted carbon chain. So you would go from 1, 2, 3, 4, 5. Okay, but say you want to do it the other way. You start by doing this one. 1, 2, 3, 4, 5. In doing so, that'd be incorrect. The correct one would be this. 1, 2, 3, 4, 5, starting from the left side, because you want to start your numbering closest to the first substituent possible. And where is that substituent? That is in carbon number 2. So we need to name this carbon. So it'd be 2. So on carbon 2, it'd be 2, and there's 1 carbon present, so it'd be methyl. 2,2-methyl. We need to figure out the parent group, which we already have. It's 5. 5 carbons is what? Pentane. So now you want to put the substituents first. So it'd be 2-methyl, and then the parent group last, pentane. So this is the correct answer for this. Okay, let's start this next one. Okay. Again, you gotta find the longest uninterrupted carbon chain before we can begin. So say we start from here, it'd be 1, 2, 3, 4, 5, 6, 7. What if you want to go up? It'd be 5 and 6. So that'd be wrong. So what if you want to start from the right side? Well, 1, 2, 3, 4. The substituent on both sides would be 4. So in this case, you would want it where to the closest substituent possible, and in this case it's just 4 either side, so I'll just stick with the left side. So there's 7 carbons present, that means the parent group would be heptane. Okay, now we got to figure out the substituent name. So it's on carbon 4, and there's 2 carbons present. 1, 2. So that'd be 4-ethyl. So now we can give it its proper name. So it would go by 4-ethyl heptane. Okay, now let's try this other one. Okay. Again, you want to find the longest carbon uninterrupted chain. In this case, it'd be this long one right over here. So it'd be 1, 2, 3, 4, 5, 6, 7, 8. Again, you want to begin the numbering system with the closest substituent possible. So since we have 8, our parent group is octane. Okay, since our parent group is octane, now we get to circle the other substituents. So there's one on 3, and there's one on 4. The one on 3, we would call it would be a methyl because it's just one carbon. Same thing with 4. There's only one carbon present, so it'd be for this one it'd be 3-methyl, and this one would be 4-methyl. So before we start naming this, you got to combine these. So it'd be 3, 4, then hyphen dimethyl. Since there's 2 methyls present on carbon 3 and carbon 4, hence the comma. So, and then we end it with octane. So that's the name of this compound. Now let's try a similar one. Okay, and this one we'll put CH3. This one we'll do CH2CH3. Keep in mind, this is 1 carbon, and this one here is 2 carbons. So that'd be ethyl. First, before we begin doing any of that, you gotta number the longest carbon chain with the closest substituent possible. So in this case, we'll start with the left side because there's a substituent on carbon number 2 and 3. So 1, 2, 3, 4, 5, 6, 7. So there are 7 carbons present in this carbon chain, meaning that its parent group is heptane. So now we get to do the substituents, and there's one on carbon number 2, and this one would be a methyl because there's only 1 carbon present. So it'd be 2-methyl. The other one would be on carbon 3, so it'd be 3-ethyl because there's 2 carbons present. Okay. So now that we have all these names here, we can begin naming. Normally people would put 2-methyl first, but that'd be incorrect because you have to order these in by alphabet, and E comes before M. So 3-ethyl has to be first. And then you'll follow up with -2 methyl, and finally the parent group, which would be heptane. So this is how you do these type of compounds. Okay, let's try a different one. Well, let's try doing this one. This would be, both of these would be methyl. Okay. You begin on the numbering on the side with the closest substituent possible with the longest carbon chain. So 1, 2, 3, 4, 5, 6, 7, 8, 9. In doing that, you have 9 carbons in your carbon chain. So the parent group for this would be nonane. Keep in mind, if there was a functional group, this would be different. The ending for nonane would be different. But in this case, there's no functional group, so we'll just keep nonane. So there is 2 substituents on carbon number 3. So how do we go about naming this? Well, you would put 3, 3 because there's 2 methyls on carbon number 3, so you have to include the comma and repeat the 3 again, hyphen dimethyl. Since there's two methyls present, you have to combine them. So there's that. So now we could give it its proper name. So it'd be 3, 3 hyphen dimethyl. Well, non-name. So this is its proper name. Okay, let's try a different one. Okay, so based on the rules that I gave you, you would start by putting 1, 2, 3, 4, 5, right? Because you think this is the longest carbon chain with the lowest substituent, with the first substituent possible, right? This way it'd be incorrect because it is not the longest carbon chain possible. In fact, you'd start up here. So it'd be 1, 2, 3, 4, 5, and 6. So this is the longest carbon chain. So you got to keep in mind the rules. You got to find the longest carbon chain possible first, and then you begin numbering. Because if you skip, you'd make a mistake and you'd do the red numbers. That'd be incorrect. I'll give you a whole totally different name. So okay, since we have 6 carbons, our parent group would be hexane. Again, if there was a functional group, this would be different, but there isn't. So our parent group is hexane, and so now we have our first substituent on carbon number 3. And so in carbon number 3, there's only 1 carbon there, so it'd be methyl. So it'd be 3 hyphen methyl. So the proper name for this compound would be, starting off with the substituent, so it'd be 3 hyphen methyl hexane. Okay. Try doing this one. Oh, just to clarify, these are methyls. Okay, so find the longest carbon chain. It's pretty obvious where it is. It'd be 1. We're starting from the right to the left. So it'd be 1, 2, because this is the closest, or I guess the lowest sum of substituent possible. So it'd be 1, 2, 3, 4, 5, 6, 7, 8. That makes the longest carbon chain. So since we have 8, our parent group is what? Octane. Again, there is no functional groups, so this stays the way it is. So now circle the substituents. So we got 1 on carbon number 2, and this one would be 2 methyl because there's only 1 carbon present. Same goes for carbon number 3, so it'd be 3 hyphen methyl. Number 6 is the same, 6 hyphen methyl. Okay. So you would start by putting these in order. So we got 1 on carbon number 2, got 1 on carbon number 3, and carbon number 6. Okay, we put a hyphen, and since we have 3 methyls here, we combine them and it'll be called tri-methyl. And then we ended with the parent group, should be octane. Okay. Let's try another one. Let's specify these for you. So in this case, you could start in either direction, left or right. It wouldn't matter. Because after carbon 1, there'd be a substituent already present. So let's just start from this side. Discuss. 3, 4, 5, 6. So we have 6. So our parent group for our longest carbon chain would be hexane. So we got hexane. So now we circle our substituents. There's 1 on 2, 3, 4, and 5. This would be 2 hyphen methyl. They're all methyls, by the way, because there's only 1 carbon present. So this would be 4 hyphen methyl, 3 hyphen methyl, 5 hyphen methyl. So you want to keep these in order. So we would have 2, comma, 3, comma, 4, comma, 5. And then hyphen, and because we have 4 methyls, it'd be called tetramethyl. And don't forget to add the parent group, hexane. So this is how you do this one. So let's do a more complicated one. So here, let's draw this. Oh, Oh, my computer. So for this one, we have to find the longest carbon chain. So, well, try finding it. So it'd be 1, 2, 3, 4, 5, 6, 7. If you were to go up, it would be 6, 7, 8. So there's that. But you can also try doing it this side. 1, 2, 3, 4, 5, 6, 7, 8. See? Or you can forget that and do this. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, forgot a number. Oh, that makes sense. Okay. So you already know that red is incorrect. You can start by going from up here. So let's just rewrite this example. Okay. So we wanted to start our numbers from up here because our first substituent would be on carbon number 3, right? So 3, 4, 5, and then we'll have one on 5. And then we'll have one on 6, 7, 8, 9. Okay. So since we have 9 carbons, our parent group is nonane. Now we get to circle our substituents. And of course, you want to start off your substituents with the lowest number possible. So in this case, it's 3. So we have 3-methyl, because there's only one carbon present. Now carbon 5 is the same thing, 5-methyl. Carbon 6 is a little bit different. There is 2 carbons present, so that'd be 6-ethyl. So when we name this compound, you want to start using the substituents first. So we have 3-methyl. But if you start with that, it'd be incorrect because you got to remember the alphabet. Got to order them by the alphabet, and E comes before M. And so you would have 6-ethyl come first. 6-ethyl hyphen 3, 5 hyphen dimethyl, because there's 2 methyls present on carbon 3 and 5, carbon 5. So, and then don't forget to add the parent group, which would be nonane. So this is the correct way of writing this carbon chain. Okay, let's do one a bit different. Okay. Oh gosh. Okay. So it's pretty obvious where our longest carbon chain is. So again by numbering 2, 3, 4, 5, 6, 7, 8, 9. Our parent group for this would be nonane. Now here we got a terp butyl. but we're not allowed to use this naming system on our test. We have to use the IUPEC naming system. And so you would circle it and you would restart the numbering system with the longest carbon chain. So for this one it'd be 1, 2. So the sub-parent group for this carbon chain would be ethyl, because there's 2 carbons present. And then you would circle the other substituents in this carbon chain. And so you would have 1, 1 hyphen dimethyl, because there's 2 methyls on carbon number 1, so that's how you would write it. So now let's give it its proper name. So we got 4. On carbon number 4, we have our hyphen parentheses 1, 1 dimethyl ethyl, because this is our subparent cosier. And then you would put nonane. So that is the correct way of writing this. So don't forget to add the commas and the parentheses. So let's try another one. Okay. So for this one, you want to find the longest carbon chain, and it's not obvious. So let's start from this direction. 2, 3, 4, 5, 6, 7, 8, 9. Let's start by doing this other direction. 1, 2, 3, 4, 5, 6, 7, 8. So in doing so, well, let's see, 5, 6, 7, 8. So we have to use the red one. Okay, because that is our longest carbon chain. Okay, now we gotta circle our substituent so we could get it out the way. Our parent group is 9 carbons, so it is nonane. Okay, now we gotta restart our numbering system on this carbon chain. We gotta find the longest one. So we would start here with 1, 2, and then 3 down here. So our sub-parent group has 3 carbons in it, and that is propyl. Now begin by circling off the other substituents in this carbon chain. So we have 1 on 2 and we have 1 on 1. And they're both methyls. So we would do, the naming for those would be 1, 2 hyphen dimethyl, because there's 2 methyls on carbon 1 and 2. So now that we have that, we can begin our proper naming system. So on carbon 4, we have hyphen parentheses 1, 2 hyphen dimethyl, and then our sub-parent group, which would be propyl, parentheses, and then we put our main parent group, which is nonane. I'm sorry, it's not 4. This is 5. I was looking at the wrong carbon chain, so we gotta look at the red one. It's 5. So there it is. So let's try a very different one than the ones we've been doing so far. Oh, it's getting slow. Okay, so for this one, where do you want to start the numbering chain? Either left or right. If you were to just put the numbers, you would have a substituent on carbon number 2 on both sides. But we can't just put them like that. You would have to go base by alphabet. And C comes before F. And so our numbering system, you would want to put it on the left side. 5. So we know this is pentane. This is our parent group. And so on carbon number 2, we have 2-chloro. So instead of saying chlorine, you would say chloro. 2-chloro -4-fluoro. And then you'd put the parent group, which would be pentane. So this is how you name these types. Let's go back to alkenes. Okay, so we would have this compound. Oh, what happened? Okay, it goes. And you would put a double bond here. So, how do you begin by numbering this? Well, you want to start with the right side because you want to give the double bond the priority. So it'd be 1, 2, 3, 4, 5. Now keep in mind, this is an alkene. Double bonds are alkene. If it was a triple bond, it'll be an alkyne. So in knowing that, you will know that you have a functional group. And so instead of saying the parent group pentane, it would be different. The ending would change into ene. So our parent group would be pentene. So we're not finished yet. Because since we have the double bond on 2 and 3, you want to start by putting it on, by numbering it on 2. So it'd be 2 hyphen pentene. Because this is where our parent group is. Okay. But we're not done yet. We're not done because this has a hydrogen. And on this side, there's also a hydrogen. And in knowing that this one is going down and this one is going up, this is a trans isomer. So you begin the naming system by placing trans first. Trans hyphen 2 hyphen pen, because this is our because there's an alkene here, so it'd be pentene. So this is our parent group. So this is the correct way of writing this. Okay, let's try a different one. happening. Okay. Let's try doing this one. Oh, here is our double bond. In this case, the numbering system, you could put on left or right if you wanted to, because it'll land on 3 regardless. So 1, 2, 3, or you could do it this side, 1, 2, 3. It's the same thing. Okay, so 1, 2, 3, 4, 5, 6. So, okay, so we have 6 carbons, so it'll be hexene, but I mean, it would normally be hexane, but there's a double bond here, which is an alkene. So our parent group would be hexene. And we're also not done here, though, because there's a hydrogen here, there's a hydrogen there, and they're both pointing up. This is a cis isomer. Okay, so you would start by putting cis hyphen, and then we have on carbon number 3, we have the alkene hyphen, and then you'll put the parent group hexene. So this is the correct way of writing this compound. So okay, let's go more complicated. Let's go to cycloalkanes. So this triangle has 3 carbons and it's a ring, so it'd be what? Cyclopropane. We did a square. There's 4 carbons and it's a ring, so it'd be cyclobutane, 4 carbons present. Did this. There is 5 carbons present and it's in a ring, so it'd be cyclopentane. Do this. There is 6 carbons present in this ring, so this is called cyclohexane. There's 7 here, so this is cycloheptane. And then the octagon, which would be octane, cyclooctane. Okay. Okay. Make sure you know those. And so now let's try an example here. We got this, we'll put a Br here, and CH3 there. How do you go about naming this? Well, I would start by putting a number 1 here, because then our next substituent would be on number 3. That's how you would do it. If you do it, if you start by doing it here, your next substituent would be on number 4, and you would want it to have it on the lowest number possible. So you want to begin the way I started. So 1, 2, 3, 4, 5. And so now that we got our numbering system in place, you already know what the parent group is for this. Parent group would be pentane, cyclo, Remember to put the cyclo first. So it'd be cyclopentane. That is our parent group. Now circle the other substituents. We have one on one, carbon 1, so it'd be 1 hyphen bromo. Remember, instead of saying bromine, you would say bromo. And keep these lowercase. And then on carbon 3, we have a methyl, because there's one carbon present. So it's 3 hyphen methyl. So now we can properly name this compound. And remember, you gotta order these by the alphabet. And B comes before M, so it'd be 1 bromo hyphen 3 hyphen methyl. And then you'll end it with the parent group, which would be cyclopentane. Okay. Okay, let's try a different one. Let's put a double bond here. And Cl. Okay, so what do we know by looking at this? We know we have a alkene. So you want to give the alkene its priority, numbering priority. So it's 1, 2, 3, 4, 5, 6. Now you can't go 1 and 2 because the alkene is in between 1 and 2 on the red side. So you would have to go to the right. You can't go to the left. Okay. So since we have 6, we know our parent group is cyclohexene. The ending changes because there's an alkene present. Okay. So now we get to circle our substituents. We have 1 on 3, we have 1 on 4, and we have 1 on 6. On 3, we have a CH2CH3. If you would expand that, you would get an ethyl because there's only 2 carbons present. So this would be 3 hyphen ethyl. On carbon number 4, you have a methyl because there's only 1 carbon present. See? 1, 2. So there you go. So and on carbon number 6, we got 6 hyphen chloro. Instead of saying chlorine, you would say chloro. So now that you know these, now we can write its proper name. Now, ethyl does come before methyl due to alphabet, but chloro comes before ethyl based on the alphabet. So you would go by 6 hyphen chloro hyphen 3 hyphen ethyl, and then methyl comes in, hyphen 4 methyl, and then you can include cyclohexene, but not like this. It'd be hyphen 1 hyphen, well actually you can actually leave it there like that because it's on 1. If it was on 2, you would have to mention that. So you could just put methyl cyclohexene. Okay. Let's try one with an alcohol group. So Okay. Since we have an alcohol present, you want to give it its priority. So you'll start by numbering to the right side. 1, 2, 3, 4, 5. So our parent group is pent. It would be pentane if there wasn't an alcohol. But since there's an alcohol here, you would have the ending of pentanol. So, and this is present on carbon number 2. So it'd be 2-pentanol. This would be the correct name for this compound. Now let's try one more. Okay. So normally you would give the first substituent its numbering, right? So you would put 1, 2 here. But in this case, since we have an alcohol present, you want to give that alcohol priority over the other substituent. So your numbering will start from the right to left. So it'd be 1, 2, 3, 4, 5, 6, and 7. So since we have 7, our parent group is heptanol. Oh, I can't write it. There you go. Heptanol, because there's an alcohol present, so the ending changes. So since we're here, we get to circle our other substituents. We have one on 4 and we have one on 6. And the 4 is just a methyl, so it's 4-methyl. And on 6, it would be 6-chloro. So you want to get these by alphabet order, and of course C comes first. So its proper name would be 6-chloro hyphen 4 methyl, and then on carbon number 3, we have our parent group and our alcohol. So it'd be heptanol. So this is the correct way of writing this carbon chain with alcohol. So I hope this helped you better understand nomenclature. So till the next one.